Hello! Solder's breadboards such as this one are great for prototyping and experimenting with general electronic circuits and microprocessor and microcontroller based digital circuits. I'm going to show you over a series of videos how to use solderless breadboards to build a simple 8-bit Motorola 6809 CPU based microcomputer and explain how it works. My name's Dave Henry, and I've had an interest in electronics and micros since I was at school back in the late 1970s, early 80s. During the COVID-19 pandemic, having a bit more time on my hands, I came across an old micro in the attic that I'd built whilst I was at school. This was based on my own design initially, which I then adapted to one published in the July 1981 Wireless World magazine. The Nanocomp 6809, as it was known, was a simple micro using the Motorola 6809 CPU. After watching Ben Eater's series of videos on building a 6502 CPU-based system on breadboards, then following up with a series building an entire CPU using basic logic chips, I decided to have a go at rebuilding the Nanocomp on breadboards. For anyone not familiar with Ben Eater's excellent series of videos, you can find these on the links below in the description. There are lots of opinions I've seen in various electronic forums about the problems using breadboards, and in particular how they can't work at high frequencies reliably. While I wouldn't recommend using a breadboard built micro for production grade applications, in my experience using good quality breadboards and following a number of breadboarding rules, then a system can be built which is quite stable. I've even successfully built a VGA 16 color video controller running at 25 MHz on breadboards. I'll be sharing these breadboarding rules in a later video, so please hit subscribe if you don't want to miss this. The great thing about breadboarding is you can enhance and adapt a design, and you'll learn much more about electronics this way than soldering components into a printed circuit board. You can also reuse all the components and the hookup wire after you've finished, so there's minimal waste, so breadboarding is green too. I'm just going to quickly cover the history of breadboards, where the name came from, and cover some of the other options for prototyping and experimenting with digital electronics and microcomputers. So where did the term breadboard come from? In the early days of electronics, before semiconductors and silicon chips, when thermionic valves and vacuum tubes started to be commonly used in the 1920s and 30s, prototyping a circuit would often be done by soldering components to screws, nails or tag strips attached to a wooden board, quite literally on a breadboard or chopping board. So the Wikipedia page on breadboards has a number of images, so an example of the early 1920s, 30s valve-based systems. You can see here the base board with the various components screwed on and then either soldered or terminal connections. And then there's some other amateur radio sites that have got other examples that I've linked to here. And again, you can see basic breadboard with screw terminals and wires and things soldered on here. One of the other examples of early breadboards that I've got personal experience of actually came from a Ladybird book. This Ladybird is a children's publisher in the UK, and in 1972 this particular book was published on making a transistor radio. It's particularly of interest because it was introduced a fairly young audience to electronics and circuit diagrams. So I'll just take you through a few pages of this, and I'll be linking to some examples of this radio as it was built from the website of Grant Searle. So making transistor radio introduced basic concepts, how basic circuits work, circuit diagrams, started with a crystal radio set, and actually developed the radio through a number of stages to become a more complex multiple transistor radio. Introduced the tools for construction, which haven't changed too much from ones we'll be using for building micros with breadboards a little bit later. And this particular book used a wooden board with brass screws and screw cups to actually trap the wires underneath the screw cups. And in fact, this was the first term I came across of breadboard here. You can see in the early days of radios, receivers are made on a baseboard, sometimes called a breadboard. We're using a form of breadboard mounting. And in fact, the plans for this radio kit were based on this wooden board marked out with the different guides here as the circuit evolved. And as you go through the circuit, you can see how it extended the design, introduced transistors. These particular transistors, I checked recently, are about £7 or £8 a transistor at the moment, so quite rare. Would make quite an expensive radio these days. So as the circuit evolved, the different components are screwed into these terminals, and over time we add more and more stages to this, and eventually the finished radio is quite complex, and we can sort of see the close to finished radio there and the circuit diagram. Now the reason why I'm showing this is because it's actually quite interesting that there's a great website from a guy called Grant Searle, has a website, searle.wales. The interesting thing about his site here is he actually has a number of different Z80 6809, similar to the one we're building, Z80 and a 6502 based sort of system, very small number of chips, and I think he also includes software for these. So this will be referenced a bit later on. But one of the most interesting things here was he has a lot of legacy electronics kits, and he also actually has some images of the radio that he built when he was young. Another common technique for prototyping is wire wrapping. This is SCMP Intrikit National Semiconductor SCAMP2 kit that was used as a prototyping solution when the processor was first released around, I think, 1976 it comes from. This particular board has printed circuit board elements and then had a prototyping area. And there were later updates to this Intrikit to upgrade to SCMP2 processor, and in fact to add a keypad and display, as you can see here. And this was actually done through wire wrap. You can see here the wire wrap sockets here are quite long, and you can see the wires are looped around each pin up to about 7 times. Now, wire wrapping is quite a robust way of building circuits. A little bit difficult to make changes to it because undoing the wrapping can be quite awkward. And in fact, you can even see that in some production computers, early production computers, used wire wrapping. When we go to this example here on Wikipedia, the digital equipment PDP-8 that used a wire wrap backplane, and this is just a picture from the wire wrapping topic in Wikipedia. This level of wire wrapping used a semi-automated machine to help do this, but wire wrapping is quite a robust technique. And in fact, there's another example here of the first IBM computer. This was the prototype of the first IBM computer, and you can see here that this was put together on a wire wrapping board, and again, not probably the easiest to trace what's going on or to debug, but this was the first working IBM computer. This Intrikit was actually the basis for the Science of Cambridge MK14, for those of you who may have heard of it. This is a copy of the first Personal Computer World magazine from 1978, which was distributed as a PDF, I think, with the 30th edition of the magazine. And included in here is the advert for the Science of Cambridge being Sinclair, became Sinclair. MK14 was very much based on this kit that National Semiconductor did for introducing the SCAMP2. So MK14 was very much based on this as well. One of the other common prototyping systems is strip board or Vera board, such as this one. This requires soldering, but it's quite simple to design and build. And with the following tool or a drill bit, you can make breaks in the tracks. So this would typically be required if you were putting an integrated circuit. On the top of the board there, you might need to break the connections between the tracks so they don't short together. Vero boards are very handy for putting together circuits, and in fact, in the NanoComp later on in later videos, I'll be using a bit of Vero board for making the keypad, just because the key switches don't easily fit into a breadboard, and you can't do a sensible keypad layout with breadboards. You really need to make this on strip boards, so we'll be using strip board for making the keypad in future videos. There are many other complicated designs of prototyping board available, many types of PCBs. This particular one, it was quite interesting. I used this for wiring up the original keypad on the NanoComp I built many years ago, and this is called Roadrunner wiring pen. It actually has special wire here coated with insulation, which is designed to burn off when soldered, and will then provide a good electrical contact. So normally what you do is, with these wiring combs, you glue the wiring combs to channels on the board, take the wiring pen, wrap it around a pin a number of times, route the wire through the comb onto other combs and then onto another pin, and then when you go through and solder these, then the electrical connection will be made. So it's similar to wire wrapping, but uses solder rather than a wire wrapping tool, and it's another useful way of prototyping. If you look at the board here, this one has multiple Eurocard connectors and also power rails and ground rails on the other side of the circuit. There are many manufacturers of these type of prototyping boards you can get of various designs, and soldering these you can make almost a sort of production quality design should you need for low volumes. So proto board like this is another potential option. The main disadvantage of all soldering solutions is that it makes it more difficult to reuse the components. You can damage the components if you're not careful with heat, and also sometimes if you use too much heat, you can sometimes lift the tracks off of the prototyping boards or Vero board or strip board. And finally, we now come on to solderless breadboards. Now, the first solderless breadboard was first patented in around 1971 by a man called Ronald Portugal. I think the patent was granted around 1973. So this is a sort of the commonly seen form of the breadboard. So we have the power rails or power strips, which are normally continuous down each side. Sometimes some breadboards have a break in the middle, so it means you have to join the two together. And then the strips across here, normally 5 or 6 strips across, joined together with a gap down the middle to allow for integrated circuits to be plugged in different sides. So this was the first patent. I remember early days of electronics in the late 70s. This is a copy of Everyday Electronics from 1978, where the Euro breadboard was being marketed. So this was a similar breadboard style. And there have been many videos produced by a number of people, including Ben Eater, on choosing breadboard. So this particular video, Ben introduces the style of breadboards that he uses and some of the justifications for it and reasons why he believes it's a good way how to prototype and experiment, and believes in particular that you'll learn more about electronic circuits through building on breadboards because you can adapt and evolve them, whereas just soldering components into a pre-built printed circuit board, you don't learn as much. Some other examples here. So Interlink Knight has done again a review of many different types of breadboards, and also one here from James Sharman as well. So the main thing that come out of all of these reviews of breadboards like this is that their quality is very variable. The cheaper ones generally will disappoint and aren't very good and not really worth it. There are 2 main manufacturers that come out of all of these reviews. One is Busboard Prototype Systems, and the other one I think was Jameco. Ben Eater recommends the Busboard Prototype Systems. The Jameco ones appear to be good, but they do cost about twice as much of the Busboard Prototype Systems ones, so there's probably not too much of a justification to spend twice the amount of money for a similar quality. So out of all of these designs, The Busboard Prototype Systems ones is probably the one that I would recommend. The BB830 is the common one. I tend to buy mine from Mauser in the United States. For folks in the UK, I think orders over £35 include free international shipping. The standard breadboard design like this, you can see they also provide copper solderable versions of this. So if you wanted to convert a circuit directly from your breadboard design into a soldered, more permanent solution, then you can buy proto boards that are suitable for that. This particular diagram is quite useful. I've copied this and printed it out on pages, and it's quite useful for mocking together the layout of more complicated circuits rather than just sort of do it by hand with components. And if we look at the images on the website, Busboard also produce transparent breadboards rather than the white. And this is quite interesting because you can see the way how the clips and things inside these things are. So on all the Busboard, power rails are continuous all the way down here. As I said, some examples do actually have a break in the middle and you have to join the two halves of them. You can see from these things certainly where the spring clips along here are. I'm not going to try and do a full sort of introduction to basic breadboards. There's quite a lot of good videos out there of people introducing basic breadboarding. I'm going to be focusing more on how to build the more complicated microcomputer versions and all sorts of issues and things that I've had building more complex circuits, and some of the advice and rules that if you follow will make life easier and more likely to have success. So one of the other breadboards that I've had for a number of years, I think I got these from Maplin, KNH, which I think is still available. You can still buy these from various sources. They're quite nice breadboards. The only issue is that the power rails at the top here are not joined, so you do need to join these links here. And when you're doing digital circuits, the main issue is that the power rails are not running down the sides here, and so if you need to tie a lot of pins to ground or to 5 volts, for example, then it makes things a little bit awkward. It is quite nice that they have a bus, these sort of bus connections down the bottom. Unfortunately, they only have 6, so really if we wanted to say a data bus or address bus, you're generally going to need 8 or more connections. So I'm sure these are great for analog circuits. There is another issue that they've got circular holes here, so there are some of the larger square cross-section pins may not fit into them. So they're decent breadboards, but probably not that ideal for building microcomputer circuits on. So we'll be using instead Busboard Prototype Systems one. The only issue I think some of the reviewers identified with these is that these ones, Busboard ones, don't actually have connectors such they have on the side on the ends. So if you wanted to connect multiple breadboards together, then you will have to connect them via some sort of method. And also that one of the reviewers noted that the spacing of these connectors on the side didn't match with some of these other breadboards. But if you're only using Busboard Prototype Systems ones, then it doesn't really matter too much. These ones are probably about half the price of the Jameco ones. So although the Jameco ones are probably very, very good, but they're about twice the price of these. These are about £8, about sort of $10, $11. So to continue our theme of prototyping and experimenting, I'll just have a quick review of some electronic kits that I've used and got experience of. During the 1970s and 80s, there are a number of electronics kits became available, in particular from Radio Shack Tandy and Maplin Electronics. I particularly like the ones with the spring terminals that allowed you to wire up different circuits and things using wires between spring terminals. Grant Searle's site has got quite an eclectic collection of electronics kits. In particular, ones I was interested in. This Philips Radionic electronics kit was one of the first ones I had. It actually had the components were on little plastic mounts with screws and bolts, and you actually went and bolted these into the circuit board. It built quite reliable circuits, such as a radio, very similar to the one that we shown earlier in the Ladybird book. The only problem with these circuit boards was that you couldn't really modify the designs very easily because the circuit boards were very much designed to fit all the experiments. So it built reliable projects, but not really great for modifying experiments and things. As I said, probably my favourite form of kit were these 201 style kits, which are very, very similar to the science fair ones in the US. This particular one I think I bought from Maplin probably about 10 or 15 years ago. Unfortunately, you don't seem to be able to get these anymore. And in this particular one, the circuit was on quite a nice board. If we take this out here, you can see here that each of the components generally has a spring clip at each side. They're all numbered, so that to make a circuit, you generally follow the instructions for joining certain numbers up to others with wires, a variety of different wires. And then there's a display panel here, so you can see sort of tuning, control switches, panel meter, and the LEDs, and even a Morse key, I think, on the side, far side over here. So I chose a particular circuit. I thought it might be interesting to try a winking LEDs, which is a multi-vibrator. It's actually a multi-vibrator circuit using 2 transistors. I've produced a slightly better circuit diagram. This one is not very easy to see, this one, so I'll show you that in a minute. And what I've done is taken this as a basic design. I actually tried to implement this on a number of different formats of breadboards and things. So the first one here is the 201 electronics kit here. And this particular circuit, when you follow it, there's a switch here, and once it turns on, we should see the LEDs blinking on the front. They're quite faint. I've already changed the resistor values. In fact, from the design, it was using, I think, 470 ohm resistors. I've changed them down to about 330 to make the lights a little brighter. They're still probably not that visible through the camera here, but when viewed from an angle, you can probably see this. So the advantage of these types of circuits is you can had quite a number of different components. So quite often there's more than one copy of a particular component. So it does allow you to vary the designs a little. So you'll see quite a few of these things have got multiple components, particularly on the transistors. As we'll see in one of the other sets, there are 2 of each type of NPN and PNP transistors here, which can be a problem if you only got one of each type. It limits what you can do. So that's probably my favorite type of electronics kit. I'll just turn it off so you don't use any more of the battery. So this is the circuit being put together in KiCad, just to make it a little bit more visible. So what we've got here is 2 LEDs with resistors to limit the current to them, 2 transistors with a resistor and a capacitor, which determines the charging time for each transistor, and that determines how frequently the LEDs blink. This is about once per second in this particular case. And the first example I've chosen to do is try the Ladybird electronics kit form. So this is one that I put together. I would have to say that this does take a little while to do. I laid out the circuit using a sort of a diagram with sort of a template from the screw cups. So I'll just hook up the circuit to power. So I've got a desk power supply, benchtop power supply here, providing 5 volts, and hopefully for all the connections, now we can see there. So we have a blinking LED circuit. So certainly it's a valid way of building breadboard circuits, but I wouldn't recommend this compared to using other systems, given it is a little bit cumbersome to do, but it is very cheap. The components for this don't cost very much. So moving on, here's the next one. This is a John Adams hot wires kit. This is a more recent electronics kit and makes use of pluggable clip components on a plastic board. We just have a look at there's a circuit I've produced here. So this is an example of the circuit, the same circuit. Took a little while to build this. You can see that in some cases you need to include spacers to make sure that the components have the same height. This particular circuit won't work, unfortunately, because there was only one of each transistor type. So we've got an NPN one or a PNP one here. So I've put it in here just to show how the circuit would look, but unfortunately this won't work and plugging in here. But you can sort of see we've got the two LEDs here, the various resistors and things. One of the problems with this kit was that there was only one of each component. So in this particular case here, we either got a 100 microfarad and a 10 microfarad. So you'd have to choose the values appropriately and modify your design. So I mean, I thought it was interesting just from a point of view of showing what a more up-to-date electronics kit. These are still available, I believe, on Amazon and other toy vendors. So you can do something like this. They provide sort of slightly more interesting components. There are sort of modular components using chips and things. So these are like sort of sound generators and other more exciting type of components. So it's quite a nice little electronics kit. Probably builds slightly more exciting things than some of the basic ones, but is a bit more difficult to experiment and develop your ideas. So now we're going to look at a breadboard solution. So here's a copy of the circuit. I did change the transistors a little bit. I didn't have enough of the tin can style transistors, so I've replaced them with some plastic BC182L on this particular case. So this is a circuit again, and as I said, sometimes I find it useful to print out one of the breadboard diagrams and actually try and lay it out first. I must admit this one's probably not that easy to see with the camera here, but it is possible to do this. Certainly on digital electronics, sometimes if you're trying to lay out some different chips and trying to work out where all the wires are going to go, it can sometimes be easier to do that like this. So with this, we're building it on a standard sort of breadboard. This is the BB830 busboard one, and so here's a rough version of the circuit. So you can see here we've got one with quite long wires. I haven't really trimmed them. No, it's quite a rough version of the circuit. We just plug in the power here and turn on the bench power supply. Hopefully we shall see this working. So there we go. We've got this particular circuit working. Now the only problem with this is that the leads are quite long and they could brush against each other. So generally, once you've got a circuit working like this, it's probably an idea to rework it. So here's a version where I've basically just tidied it up a little bit, so you can see the wires are a bit neater. I've trimmed some of the components down and the resistors are now actually now cut to length. So you can see now that compared to the two before, you can see one's a lot neater than the other. To put together this type of circuit, probably takes about 10 minutes or so. Certainly a lot quicker than the brass cup breadboard approach. So if we just plug this in here and see whether or not this one works. That one works as well. Excellent, great. So very simple circuit, but just showing the different approaches and different ways to experiment. I obviously prefer using breadboards for doing this, but certainly some of the electronics kits in the past would allow a certain amount of experimentation and substitute different components, see what happens if you combine different, multiple circuits together into one, for example. So that's my introduction to breadboards and electronics prototyping and experimenting. In the next video, I'll introduce you to the Nanocomp microprocessor design and explain how it works, and share my breadboarding rules and tips. Hit subscribe if you don't want to miss out. Thank you. Bye.